Today we are going to simulate a simple yet powerful network setup in CISCO Packet Tracer. In this scenario, a server is connected to a LAN network through a router, and the server will function as a web server. We begin with the initial setup. Two computers are placed in a LAN and connected via a switch. The IP addresses assigned to these computers are 192.168.10.2 and 192.168.10.3. The switch itself is then connected to a router, which provides the gateway for communication beyond the LAN. On the router's LAN-facing interface, we assign the IP address 192.168.10.1. This acts as the default gateway for the computers. In practical terms, this means that whenever the computers in the LAN need to communicate with devices outside their local network, they will forward their traffic through this gateway. Now, on the other side of the router, we connect the server. The server is assigned the IP address 192.168.20.2, while the router's interface facing the server is configured with 192.168.20.1. This address serves as the default gateway for the server, ensuring proper communication back through the router. The final step in this setup is to configure DNS and URL settings. By doing so, we allow the computers in the LAN to access the server not just by its IP address, but by a human-readable name, in this case, the URL syamaprasadcollegecsdept. This completes the configuration, enabling seamless communication between the LAN clients and the web server through the router. Let us now walk through the process using CISCO Packet Tracer. We begin by selecting a PC from the End Devices menu and placing it onto the workspace. In the same way, we add two computers, PC1 and PC2, to our setup. Next, we select a switch and a router from the device list and drop them onto the workspace. To complete the network, we also choose a server from the End Devices category and place it alongside the other components. Once the devices are in place, we move on to the connections. Using the Auto Connection tool, we link PC1 and PC2 to the switch. With the same tool, we establish a connection between the switch and the router. Finally, we connect the server to the router, completing the basic structure of our network. Now let us move on to the configuration of our devices. We begin with PC1. Under the Configuration tab, in the Fast Ethernet section, we assign the IP address 192.168.10.2 along with the subnet mask 255.255.255.0. In the same way, we configure PC2, giving it the IP address 192.168.10.3 with the same subnet mask. Next, we turn to the router. On the interface Gigabit Ethernet 00, we set the IP address to 192.168.10.1. This will act as the default gateway for the LAN side. On the server-facing interface, we assign the IP address 192.168.20.1. At this stage, it is important to ensure that the port status is enabled so that communication can take place. Now we configure the server. The server is assigned the IP address 192.168.20.2 with the subnet mask 255.255.255.0. Under the Services tab, we enable DNS. Under the Config tab, we also set the default gateway to 192.168.20.1 and the DNS server IP to 192.168.20.2. Finally, we configure the PCs to recognize the gateway and DNS. In the DNS service, we enter the name Syamaprasad CISCO and activate DNS services. For the address, we provide the server's IP 192.168.20.2, add it, and save the configuration. On PC2, we set the default gateway as 192.168.10.1 and the DNS server IP as 192.168.20.2. Similarly, on PC1, we assign the same default gateway and DNS server address. With these steps completed, the network is now properly configured for communication between the LAN and the web server. Now it is time to verify whether our connections have been made correctly. We begin by clicking on PC1. Under the Desktop tab, we open the command prompt. From here, we use the ping command to test connectivity. First, we ping the other computer in the LAN to ensure that local communication is working. Next, we ping the server to confirm that the connection through the router is also successful. By observing the replies, we can clearly see whether the packets are being transmitted and received properly. This step assures us that the network configuration is complete and that both the LAN devices and the server are communicating as expected. We can also verify communication using the PDU tool in CISCO Packet Tracer. To demonstrate, let us check the packet flow between PC1 and PC2. First, we select the PDU tool, then click on PC1 as the source and PC2 as the destination. Immediately, the event window displays the transmission details. In the same way, we can repeat this process for all possible combinations, whether between the PCs or between a PC and the server. Each time, the event window provides a clear indication of the packet movement and the result. As we observe, the event window confirms that all communications are successful, showing that our network setup is functioning exactly as intended. Now let us move on to visualizing the packet transfer in our network. To begin, we select the PDU tool and click on PC1 as the source, followed by the server as the destination. Once this is done, we switch to simulation mode to observe how the packet travels across the network. In the same way, we can also test communication from both PC1 and PC2 to the server. Each time, the simulation clearly shows the packet being generated at the source, moving through the switch and router, and finally reaching the server. This visualization helps us confirm that the data flow is working correctly and that our network setup is successfully transmitting packets end to end. Now let us test our configuration by opening the web page using the URL we have set. We begin with PC1. Under the Desktop tab, we select the web browser option and type in the URL syamaprasadcollegecsdept. Immediately, the page is displayed. What we see here is the default web page provided by CISCO Packet Tracer, confirming that the server is responding correctly. In the same way, we can repeat the process from PC2. By opening the web browser and entering the same URL, we once again observe the default page being displayed. This verifies that both computers in the LAN are able to access the server successfully through the router, completing our simulation. And with that, we have successfully completed our network simulation in CISCO Packet Tracer. We began by setting up two computers in a LAN, connected through a switch, and then linked the switch to a router. On the other side of the router, we connected our server, which was configured to act as a web server. We carefully assigned IP addresses, configured gateways, and enabled DNS services so that the computers could access the server not just by its IP address, but by the URL syamaprasadcollegecsdept. After verifying connectivity with the ping command, we used the PDU tool and simulation mode to visualize packet transfers across the network. Finally, we tested the web browser on both PCs and confirmed that the server's default page was displayed successfully. This demonstration shows how a LAN can communicate with a server through a router, highlights the importance of IP addressing and DNS configuration, and validates the complete flow of data from client to server. With these steps, we have built and tested a fully functional client-server network model inside CISCO Packet Tracer.